In the last video, we determined the number of bits borrowed and the custom subnet mask for our scenario. In this video, we'll calculate the increment for the subnet address and determine the host ranges for the broadcast address for each subnet. The fourth rule of subnetting tells us that the decimal value of the last bit borrowed gives us the increment of the network address in the subnets and the network address of the first usable subnet. The decimal value of the last bit we borrowed is 4. That means that the network address of the subnets are incremented by 4 in the third octet. This is the part that can confuse students. With a little bit of practice, it's easy to create a custom subnet masks with a Class C address. It isn't that much harder to create them with a different class of address. We borrowed these bits from the third octet, so that's where the subnets need to be incremented, in the third octet. Since the Class B address we've been assigned is 128.16.0.0, and we'll only be changing numbers in the last two octets, I'll only write down those numbers. The network address for the first subnet is always 0, so I'll write down 0.0. We said that the increment of 4 occurs in the third octet, so subnet 1's network address is 4.0. Subnet 2's network address is 8.0. And subnet 3's network address is 12.0. Recall from the last video that the broadcast address of a subnet is always one number less than the network or wire address of the next subnet. One number less than 4.0 is 3.255. The first subnet created is always unusable since it contains the network or wire address for the class of address that we're working with, so we'll mark it as unusable. Let's double check the broadcast address of subnet 0. We said that if an address contains all binary 1s in the host portion, it's a broadcast address. Writing 3 in the third octet, we put a binary 1 in the 2's column and a binary 1 in the 1's column. Writing 255 in the fourth octet, we put 8 binary 1s in the fourth octet. So we see that we do have all binary 1s in the host portion, so this is a broadcast address. So we said the broadcast address of subnet 0 is 3.255, which is one number less than the network address of subnet 1. The network address of subnet 2 is 8.0, so the broadcast address of subnet 1 is 7.255. The network address of subnet 3 is 12.0, so the broadcast address of subnet 2 is 11.255. And if we wrote subnet 4 in, its network address would be 16.0, so the broadcast address of subnet 3 is 15.255. All of these subnets are usable, so let's record that fact. The last step is to fill in the host range. Once we've recorded the network and broadcast addresses, filling in the range of host addresses is very simple. We said that the first available host IP address is one number greater than the network address for the subnet, or .0.1. The last available host address is one number less than the broadcast address, or in this case, 3.254. The network address of subnet 1 is 4.0, so the first available host address is 4.1. The broadcast address of subnet 1 is 7.255, so the last available host IP address is 7.254. The network address of subnet 2 is 8.0, so the first available host address is 8.1. And the broadcast address is 11.255, so the last available host IP address is 11.254. And for subnet 3, the network address is 12.0, so the first available host address is 12.1. The broadcast address is 15.255, so the last available host address is 15.254. You can check any of these addresses out by writing it in binary and seeing if the host bits are all zeros, the network address or all ones, the broadcast address. We follow the same rules of subnetting for a Class B address as we do with the Class C address. The trick is to know which octet to increment the network address in. The best way to become proficient in subnetting is to work through examples on your own for practice.